Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Umaka, and I am your instructor. Today, I'll be showing you the structural design of this building you are seeing here on my screen. Now, this building is a commercial building that consists of a shopping plaza, consists of a showroom, and then a workshop. Now, this building, we are going to be performing the structural framing of this building, then the structural modeling, and then move to the structural analysis, and then structural design, and then the structural detailing, and then the construction of this building. And all this will take place, and we are going to conclude all this at least 3 months, depending on how the client funds for the project and all that. But before we get to the construction, we will have to first perform the structural design since the architect is done already with the building drawing. And also the mechanical drawing is also ready, and all other drawings except the structural drawing which we are about to do today. So on this building right now, we are going to perform the structural design of this building and all that. Now, before you must perform your structural design, many stages are to come first before the final stage, which is design and detailing. Now, the first phase, which is the comes first, is for you to understand your drawing or to understand the building plan, which in line is all about the structural framing. Because without you understanding the building, this building plan you're seeing here, you won't be able to understand the structure, how to frame the structure, and how to transfer the load between each of the members, column, beam, slab, and all that. So you have to understand the building first, the plan, before you can then move on to the structural framing. And that is what we are going to do for today, which is the structural framing and then the structural modeling. So it will be of different phases. So our advice, if you can follow up this video, our advice you follow up, because this will take you step by step on how to do all that. And trust me, I will be taking you to sites using virtual view and all that to show during the construction how it will look like and all that, and also the stages of the construction too. That's fine. So right now, on this plan that we have here right now, you can see that this is the plan view of this building you are seeing here. Now this is the ground floor and this is the first floor and all that, and then this is the roof plan. Okay, and then also this is the 2D elevations, the left view, the right view, as you can see that, and then this is the front view. Yeah, and then this is the back view, correct. And then we have some kind of fence design here, which although this fence will not follow for the structural design, and that all we are doing the design for is for the building itself. Okay, that's fine. So all these are contained on this AutoCAD CAD file, and that knowing the principle how we operate here on Ekidel, any bidding plan we are using, we always give out the bidding plan. That is, if we got the permission. So we are going to also attach the this CAD file link to this video below. So if you want to follow up to this video design and all that, you can then purchase this CAD file and then follow up that, knowing that all our CAD files are less than or up to $1. That's all. That's fine. So with this now, let's now begin with the structural framing of this building you are seeing here. And we are going to start with the building plan. That okay? That's fine. So right now on the building plan here, you can see that the building plan came with some kind of column points and all that. And also grid lines too came with it too. But we are not going to use this. We are going to remove all the column points and also the grid lines, and then impute our structural grid lines and also structural column points and all that. That's fine. Okay, so let's now begin. But before we start, please, if you are new on Ekidel, consider subscribing, and if you're on old subscribers, consider joining the Ekidel mentorship training, okay, which is a one-on-one training. Note, it is not free, it's a paid one. That's fine. So right now, let's now begin now. So to begin your structural framing, the first thing to do, knowing the culture here, you have to copy out this building out, copy it out and have a sample or a duplicate, right? So that in case there's any mistake, you can always go back to the original and then do what? And take back your reference from there. So right now we have just made a copy of this building you are seeing here. The next thing to do right now is to now remove what we don't want to see, because basically a structural um, framing plan is meant to be neat. What I mean by neat, I mean by we don't need all these furniture symbols and all that. We don't need some kind of unnecessary things on our structural framing plan. All what we need are the important members and all that. So with this now, I'm going to clean up this building plan by removing all these furniture symbols. All right. Now, most people sees structural framing as a that it takes time, okay? But the truth is that if you want to perform a perfect structural design, you must have to spend time on your structural framing, because it is during this stage that you'll be able to understand the structure a lot and also how the buildings are going to frame. So in my own way, I always advise that you spend time on your structural framing. Even if it will take you 1 hour, 2 hours to perform your framing of your structure, spend time to do that, okay? I know that, because if you don't spend time to do that and just rush in to go and do your modeling, you might model what is not correct. All right. But by the time you have spent time to understand and frame your structure, you will see that you have already known how your members are going to be connected, how the load are going to be transferred and all that. Now, when you get to the software to perform the modeling and design, you will see that you will be able to note when the software um, is giving you what you don't want, okay? Because basically you are not meant to depend on the software, you are just to use the software to make your work faster, okay? So don't depend on the software, you have to use the software to make your work faster, because software goes by the rule, whatever you input is what it will bring out for you. So whatever input you give is the output you will get. Okay, that's fine. So with this now, I'm just trying to use this means now to remove the things that are not necessary, which are the furniture, symbols, and all that. Okay, I don't need all those things right now. So with that now, I'll then remove all these and then I can leave this other one here. Yeah, that's fine. So I'll take this off to here. That's fine. This goes and then this goes here. This let me see what is that. This is a retain existing fence. So I don't need all this right now. Now same thing. So I don't also need the dimension. Note that I am working this on the copied plan. You can see the main one here. We still have all those features here. Okay, that's why I say always copy out. Okay, that's fine. So with this, I'll then go back to the copied one, which is here, and then I'll to now remove my dimension. Just to be fast on this, I'll have to click on one of them, right click, and I'll do what say select similar. Okay, right now, but note that since this original is still on this same sheet, you have to do what? Hold your shift key and then highlight this original one to do what? Deselect. Else, you also remove these dimensions here. Okay, that is the function of what quick select. It will select all the types of that particular layer or elements on that drawing sheet. So with this now, I'll type E, enter, and everything goes off it. That's fine. I don't also need all these sections, symbols, and all that. I don't need all this. So I'll take this off and also take this off here. That's fine. I'll also take this off here and then take all these. I'll just right click and do a similar. Let me see if that will work. That's fine. It works. So I'll come again now, hold my shift key and make sure I just do a deselect this other one here. That's fine. And then I'll come now and type E, enter. That's fine. So on this now, I will then come to this place. Now you can see that how the plan now is a bit neat and all that. So with this, I will then do what? I think we have almost gotten to that level. That's fine. So with this, nothing is a bit neat. I will leave all these grid lines as they are here because I want to use them also because I feel that they are well arranged. Now the next thing now, I will also remove this line of existing fence, something like this, and then take this off. That's fine. And then I'll leave this canopy here because this shows a canopy which you can see here. Let me just show you that guy right now, which you can see here. Let me see. Yeah, this is the canopy you're seeing there. Although this cannot, we might ignore this to be a structural element, yeah, because this can have yeah, we can ignore this here, but we can still model this type also as a slab which will have some kind of openings, as you can see right now. That's fine. So I'll just leave this as it is. We can use that for a cantilever slab, although not carrying any load. So I'll leave that canopy which you're seeing here and that. So with this now, I will then remove, I don't need this. I'll take this off and also remove this now. That's fine. So with this now, you can see what we've just done right now. The next thing now, just to carry you along on how to perform your framing, I'm going to remove these columns that came with the building plan because first, you as an engineer need to place your column points and all that. So by doing this right now, I'll just click on one of the columns. Alright, right click now and then do what? Select similar. Don't forget, anytime you do select similar, make sure you have to go and look at the ones you don't want to remove by doing the shift key. Hold the shift key down and then do what? Highlight them. So with this now, only the columns on this copied one are being what? Selected. Okay, that's fine. So I'll come now and do what? Type E, enter. E is to erase. So with this, I can see that we don't have anything again here. Now, this is now where the game begins because your column points are to be introduced based on the column spacing rules and all that. Okay, most younger engineers don't know the rules on how to place their columns. So with this, I'll be telling you the simple principle on how to place your columns and the size of your column, minimum size and all that, okay, to use. Okay, so with this now, let's now go into the column placement stage. Okay, that's fine. Now, before we want place our column points, there are two things we are meant to do. The first thing is to create our grid lines, but fortunately for us, we already have grid lines on this building plan, as you can see, but I'll just show you a simple way to create a building plan in case you don't have grid lines on your building plan. Okay, that's fine. So with this, okay, let me just assume that we don't have a grid line here, okay, just to carry everyone along. Yeah, so with this now, let me remove all these grid lines which I have here. I think if I take this off now, you can see this is how most building plan might appear, just like this without a grid line. Okay, I know that. But when you have this, the first thing to do is to create your your grid lines, which is also called axis. Okay, that's fine. Now, since we're using the software Protastructure for our design, we are going to create a layer and call one grid and call the other one column. Okay, that's fine. So with this now, I'll just type what? LA, that's layer. Now on this now, I'll then come here and click on this place that says what? New, this point here. Now I'll click on this place now, then it will now display this. I'll just type this now and call it what? Grid. That's fine, grid. And I'll make sure I choose my color correctly. I want to choose red symbol, that red color as for my grid line colors. Okay, that's fine. And then I'll call again, click again, new one here, new, and then call it what? Column. So this is the two layers that we need, which are very, very important. I want to use green for my column color, right? Now, I'll also come in and say line weight and choose for the column. I want to use 0 0.3. Always use 0 0.3 or and above. Let me say 0 0.5. That's fine. I'll say okay. So with this, since we now have grid line and column, this is the most important layers that you need for your structural framing. All other layers are secondary. Okay, that's fine. So with this now, let's now go on here. Okay, that's fine. So I'll come now and then close here. So right now that we have already created our two grid lines, grid line and columns, I want to start insert my column, my grid lines. So first I'll come here and make sure I choose the layer grid line and make sure here is by layer, and by layer. That's fine. So it will take all the properties that was set on these layers. Okay, that's fine. So with this now, I will then come and then begin to place my grid lines. Now, grid lines are of two primary types. First is the vertical grid lines, and then we have what? The horizontal grid lines. We can also have inclined on that, but these two are the most important one. That's fine. So with this now, let's now begin to create for our what? Horizontal grid lines. Now, you create your grid lines where you want your structural members to be. And when I mean by structural members, I mean by what? I mean by the columns, the beams, the walls. Now, when I mean by walls, I mean structural walls, not block walls, structural walls. Now, the column, the beams, the structural walls, and your slab. These are the structural members, which I mean. So in this place right now, the two structural members that we have here currently now, which I want to do is towards the beams and then the columns. Okay. So with that now, I'm going to create my grid lines or my axis based on the point where I want to place my grid line, my columns and my beams. Okay, that's fine. So with this now, I'll begin to create my horizontal grid lines. So to do that, I'll type what? XL. XL simply means what? Construction line. So I'll type XL. You can see that. Enter, and I'll type H. Enter. That H there simply means that it's going to create for what? Horizontal grid lines. Now type enter. You can see that right now. So with this now, I'm going to locate, you have to locate the midpoint of this wall, of this wall, and place your what? Your grid lines. Now you can see that if I put my cursor here, I'm going to have this point showing my what? My center point of this wall. But if you can't get your midpoint, what you do, just press escape, press line, that's L, enter, and then click on any point of the wall here, and then come back and click on any point of the wall here. Make sure they are straight. Now you get this division line for this wall. Now type XL, enter, and H, enter. Then come here, locate the midpoint of this line which was created, and then click on that place. Automatically right now, they remove this one here. You will have your first grid lines being what? You can see it here right now. So with this again now, let's now create also for the vertical grid lines. So I'll do the same thing again first. L, enter. Divide this wall vertical into two parts by clicking this line, and then come now XL, enter, V, enter, and then click on this place here, and then you can see that. Make sure you remove this other one, else you'll be having some kind of shortcut grid lines on your modeling during the modeling of this building. Okay, that's fine. So I'll come and do what? E, enter, that's okay. So with this, I can see that we now have what? The first vertical grid lines and also the horizontal grid lines here. So we will now do what? Copy each of them now to do what? Place on all other ones. Now, if you look at this, before you copy, look at your wall thickness and all that, and make sure that they are the same before you can copy a reference point to other walls. Okay, now if I go and measure my wall thickness, now you can see that the wall size they are using, or the block wall thickness for this building, is what? 230. You can see that, or what? 225. Okay, that's fine. So you can see that this is what? 230 here. Let me measure it again right now. 230 block wall, or what? 225 block wall, which in inches, you can call it 9 inches block wall. Okay, that's fine. So with this now, I'll then come and copy this vertical grid line now, and I'll type CP or CO, which means so copy, enter. Now I'll choose a reference point around the outer point here, and I'll begin to do what? Begin to click all the outer points here and all that. So this is just to be fast on this. Else you can also do to create each of the walls by dividing them into two, but you can take more time for yourself. But just to be fast, just do this and do right now. Okay, that's fine. So with this now again, you can also see that we also have a line of beam here. This is a line of beam. You can see that it's going straight down all this way. So I'll come again and place this here. That's fine. So with this now, with this, we will then come now. Now we have not placed that one here. So I'll come again right now. Click on this CP or CO. Make sure I pick my reference. I can choose to pick from inner one here right now, reference point here. But I'll make sure I come also here and pick this inner one here too. That's fine. So with this now, you can see that we have created what? All the vertical grid lines. Okay. We'll also copy the horizontal one too by doing what? Clicking on it, type CP or CO, enter, and then come now, pick a reference point on the outer wall here, and make sure I begin to click on my outer wall as my reference point, which I picked before, and then make sure you choose the major walls and all that. But if you can locate that first, make sure you put your grid lines on all the walls. Later, you can begin to choose your major walls. Okay, that's fine. So with this now, I'll then come now, click on this. Okay, that's fine. And then also come here and click on this too. That's fine. Sorry, this just type U, enter. U is to undo. Even if you're not sure of what you just clicked, then make sure you click directly the point. That's fine. Then I'll come again right now, come here and then click here. That's fine. So with this, let me see right now. Let me see. That's okay. That's okay. That's okay. That's okay. That's fine. So with this now, let's now come to this other side here. Let me see. Everything now looks okay. I don't need this line of wall here, but I'll just put this here first. Yeah, that's fine. So with this, now you can see that we have now created what? The vertical grid lines and also the horizontal grid lines. Now, since we used a what line of what XL line, this line doesn't have an end. You can see that right now. So we are going to do what? We are going to trim off the excessive part by doing what? Creating a boundary line, by creating a rectangle boundary around this building like this. Okay, that's fine. So I'll type what? Rec means what? Rectangle. Enter. And I'll come now, click, just take a boundary like this now. Come here, take a reference boundary like this. Use your eye gauge to monitor that, and then just click on this like this. Now that's fine. So with this now, you can see the boundary line now. I'll then click on this boundary line, type TR, enter, and then remove this, and then remove this, and remove, click on this just to trim off all this excessive one here. That's fine. And then come now and click on this boundary line, which I just did for just to trim off, and then type E, enter. E is to erase. That's fine. So if maybe this line seems too short for you, this point, you can just highlight it right now like this. Okay, that's fine. And type S, enter. S is to stretch. Okay, make sure the line is straight by pressing F8 key, and then just stretch a bit. Okay, that's fine. A bit, and then click on this place here. That's fine. Okay, so right now you can see that we have now created what? The vertical grid lines and then also the horizontal grid lines of this building. Okay, that's fine. So basically, you are meant to create your structural grid lines. Don't always depend on the grid lines that came with the what? Architectural plan. Okay, always create your own structural grid line, because your own grid lines is what they are going to use for the building what setting out. Okay, that's fine. So make sure you create your own grid lines. But if you want to rely on the grid line that came with the building plan, then you must have to choose the ones you want carefully. Okay, that's fine. But with this, you can see that this is how to create your grid lines. Okay, so right now that we are done with the grid line creating, now we'll then move on to the column placement. Okay, which is the column position. So with this now, I'll then come here and then click on this, and then click on what layer, and choose what column. Make sure this is by layer, and by layer, so that they will pick what they have on this layer property here. That's fine. So with this now, you can now see that we now have this column now. Okay, that this column layer now. Now to create your column, the best thing to do is to use rectangle to create your column. Don't always use line to create your column, because if you use line to create your column like this, it happens that this column will like be will not be a single element column. You can see that it has different segments. Okay, and the software Protastructure does not want you to do that. It wants to see this column as a single element, like a polyline, else it will not show on the software as a column element or member. So you have to make sure to use a rectangle like this to create your column. So you can see that there are two different things between this column. This is a single element, and this is not a single element. Can you see that? This is segmented. Okay, now you can see that this is a single element. That's fine. So we are going to use rectangle to create our column. Okay, that's fine. Now before we enter column placement, the question should be, or that will come to your mind now, is what is the minimum size of column I am to choose as a structural engineer, or for a building, or for a particular building. Okay, now note that this is a one-story building that you're seeing here. Now the column size that you assume when you're to design a one-story building is different from a column size you are to assume when you're to design a 5-story or 10-story building. Okay, each of this one-story building is a low-rise building, 10-story building is a high-rise building. Okay, so each of these buildings have their own principle on how to make your structural or how to choose your structural member size or section wisely. Okay, that's fine. But based on Eurocode, Eurocode or BS code or any other design code have the lowest size of column, at least that you are meant to assume. Then if there is any failure along the line, then you can choose to do what? Increase the size. Okay, that's fine. And knowing that column has different shapes and all that, we have square shape, rectangular shape, circular shape, trapezoidal shape, and different kind of shapes. But the most popular type of shape of column are circular, circular, rectangular, and square. Now, among these three, there are purposes or there are ways that you are meant to use them. Among the square, rectangular, and circular, the most common used one is a square column. That's because it's more common to use. And now there are some situations that you are meant to use a rectangular column. Most times, when the square column cannot be able to carry the load or to withstand the load of that structure, then you will have to do what? To improvise and increase the column size based on the length. If you still want the column to be within the block wall, to hide inside the block wall, instead of increasing the square column above or more than the thickness of the block wall thickness, what you will do is to increase one part or one side of the that square column, and once you increase one part it becomes what? A rectangular column. Although there are some situations where you have to start your assumption with rectangular columns. Yeah. Then circular columns too are mostly used for aesthetics, although there are some structural design that will require you to use circular columns, okay? Because of the way they are carrying their loads and all that, okay? That's fine because each of those columns, shapes and all that carries their loads differently or transfer their load differently to the foundation. So each of these have their own carrying capacity of load on that. Okay, that's fine. But based on this building, this is just a one-story building. I will be assuming a square column first. If there is any failure, and I want the column to still be within the block wall, then I will then move to do what? Choose a rectangular column. But that will be during the design check. Okay. After you are done with the structural analysis and design, we're now going to do what? Check the each of the members, not that to see if anyone is failing and also why they are passing. Because you must have to question why are you passing or why are you failing. Okay, that's fine. That's okay. So with this now, the principle of column size is that first, let your column should not be exposed outside the block wall, because if it is exposed outside the block wall, it might distort the aesthetics of the building. Imagine that a column now is just shooting out. Let me say a column is shooting out somewhere around this place here. All right, you will see that the beauty of this structure is not how it was designed for, is no longer how you, the structural engineer, has proposed the building. You have just defaced the structure. So it is better that someone seeing the building now, they'll be wondering where the columns are because you hide the columns inside the block wall. So basically, structural design or structural engineering is all about wonder. You have to design to make people to wonder how you came up with this kind of design, I know that, okay? So make sure you try your best to hide your columns inside your block walls, okay? But there are some kind of buildings that you are designing, high-rise buildings, that your set of column are meant to shoot out the from the from the block wall. You must not have to follow the set of block wall, but there are some things they use to cover it up, which are claddings. Okay, but that will be a different case altogether or lesson altogether. But for today, we are focusing on just this one story building. Okay, that's fine. So now to now begin your column sizing, the best way to do is to do what? Is to choose 225 by 225 column size, knowing that the common size of block walls that are used for one story building or for story buildings and all that is what 9 inches block wall, which is 225 by what 225. Okay, that's fine. So right now we are going to do what? Click on what? Just a rectangle, rec, enter, and then click on anywhere at any point. Then type 225. Then press the tab key, tab 225, and then press enter key. So with this now, automatically we have just gotten our 225 by 225 what block wall. If you check right now from this to this 225, can you see that? And again, the width is also 225. Okay, that's fine. Can you see that? That's fine. So with this now, we have just created our first column point. Okay, that's fine. So we then come now and copy this, copy or move. I can choose to move it. Move this now from the point of the from this midpoint here. All right, midpoint here. Move this and then come to this place and establish our first column point. Let me come now and put this here. That's fine. Now, another way to place your column points is what? Very, very fast. Type rec, okay, enter, then come here, click on this first point here, and then click on the last point here. Automatically, you have just shaped like the column with the thickness or the size, yeah, with the block wall size. Okay, that's fine. But if we check these two now, basically this block wall is 230 block wall, as you can see that. Can you see that? And then the column that we did here was what 225. That's why you can see that there is kind of what allowance here and all that. Okay, that's fine. So right now, either 225 or 230, they are still the same thing, just 5 millimeter difference. Okay, almost the same thing. So what we do right now is that do what is to use this type, which we just do right now by doing what rec enter. All right, and come here, establish this, click on the first point here and click on this last point here. Okay, to create this again, you can also do this way too. Rec enter, then click anywhere 230 by tab 230. To that word by, just press your tab key or your comma key. Your comma key is also by. Then to press the, do not type in the length, okay, and press enter. Okay, so we now have this now. You can also move this now, move these two to this other place here. Now you can see how now, sorry, make sure they are at the center point. Okay, make sure at the center point. Okay, that's fine. I'll come now and keep this here. Okay, that's fine. So with this, now you can now see what you do now. The question now will be, where should you place your column? At what distance are you to place your column? Now this is where the structural engineering comes to play. Because if you place much columns, if you put in much, this thing is showing green, and it's for me it doesn't showing well. Let me change it to like blue for you to see very well. Okay, that's fine. Let me just change to blue for you to see very well, because I believe it's not showing well right now. I'll come here right now and change to blue to see it well. Let me see. Yeah, correct. It's fine. So this blue now shows well. Okay, that's fine. So now the question now will now be, what are the, what is the distance I am to choose for my column points? This is where most engineers get confused. Most people get confused because now, note that when you are performing your structural framing, you are doing two things. One, you are looking out for the stability of the structure to make sure the structure is at equilibrium, to make sure all the load transfer is balanced. Two, you also put into consideration the costs of the structure, because if you have many columns on the building, yes, the structure will be stable, but it will be too expensive. That you have many columns on your structure, that does not mean that your structure will stand or that it will not collapse. No. Someone that has 40 columns on the same building plan and the other person has 14 columns on the same building plan, the one of 40 column might collapse. the one of 14 columns might stand, or two of them might stand. So what does that tells you? When you are doing your structural design, it's not by placing much columns that will make the building to stand. No. There is one saying in my country, Nigeria, like Igbo men don't like paying for structural design. So what they do, they just tell the guy at site or the engineer at site, every 2 meter put a column. Now, I call that penny wise pound foolish, because they believe that they don't want to give the structural engineer money or pay the man money to perform the design for them, but they will say every 2 meter or 2.5 meter or 3 meter put a column. Now you see that by the time when they are building their house, you will see columns will appear as if they are planting flowers. You will see columns everywhere. Now, to to them they will say, the building is too solid, right? But that is madness. It's madness, because if that building is carrying 40 columns, a, a good engineer that designed a structure can use 14 columns or 10 columns to still carry that same building, and it will still be stable. You can get that. So you can see that they just wasted money of 30 columns. So I call that penny wise pound foolish. So it is good to perform while you're doing your structural framing. You also bear in mind that you are also considering the cost of that structure, because a good structural design of a building or of a structure must be stable and should not be too expensive for the clients to afford. Because if it is too expensive, the client will not be able to afford it, and your design is not feasible. Your design is not like does did not come to reality. So, of what purpose or of what use is your design? Do you get right? That's fine. So with this now, let's now so my advice for column based on experience over the years, my advice on column spacing is that for younger engineers, do not allow your column spacing to be more than 6 meters. Now, when I mean by column spacing, what do I mean? You can see that I have a column here. I also have a column here. All right. I have a column here. Watch. I also have a column here. Now, the spacing of the column is that distance between this column and this column is the distance I'm talking about. Now, the distance between each of the columns, I know that, should at least not be more than 6 meters, because from experience, once a column spacing or span is more than 6 meters in spacing, automatically the beam that is running, that is connecting that two columns together, will also be 6 meters span. And once a beam is up to 6 meters span and above, what happens is that the depth of the beam, you should be expecting 600 millimeter depth of beam and above. Two, the reinforcement sizes tends to increase from 16 millimeter, which is the minimum, to 20 diameter, 25 diameter, and all that. And also the number of reinforcements will also increase. So just to guide yourself within the limits, please try to make sure your column spacing shouldn't be more than 6 meters. You can begin to play around 4.5, 5.0, and all that. Although there are some circumstances that will come that you have to span your column spacing up to 10 meters. I have designed 13 meters spacing before, column spacing before, where I have 13 meters beam length. But those kind of ones, those types are, you have to come with experience to do all that, okay? That's fine. So for younger engineers' sake, please try to make sure that your column spacing is less than 6 meters, okay? That's fine. So I'll be going with that rule right now, that rule of column spacing less than 6 meters, okay? That's fine. So with this now, I will then come now and let me now measure from this now to this here. What do I have? I have 4.865 meters, okay? That's fine. That's 4,865 millimeter. That's fine. Now, someone will now ask, why not I put a column here? Yeah, it's a choice. Actually, it's a choice. Okay, it's basically your choice, but also there is also a rule in structural design that around your column or around your staircase, you should have what? Column around your staircase, okay? There are reasons for that because the staircase on its own is a load, all right, exerted on this beam and on these lines of walls and all that. So in that rule, I will then come now and place a column here, but this doesn't mean that this building cannot stand without that. It can stand without this column here because the span from here to here is just 4.865 meters. So, but I want to place a column here. Okay, that's fine. So with this now, I will then continue again. I'll copy this now. Just copy this now from center point here. Okay, that's fine. And then I'll then move to, I'll come here now and place a column, and I'll come again here and place a column. Now listen, column placement depends solely on you as a structural engineer. Nobody will advise you on how to place your column or your column point or position. Most times, the architect tends to put the column points for you, just as you see as the architect did on this other one here. This is the original. Can you see that? It has column placed for me on that. You are to look at the column points that the architect has placed for you to see if you want to use it. If it is okay for you, when you have examined everything and it's okay for you, you can go with it. But if it is too much, you can remove few of them. What they did was they are just guiding you that if you're to put your columns, please try and see if this column arrangement will like fit in. If it doesn't fit in, then put in your own. That's what they mean by that. Doesn't mean that you are meant to that is a must. You must go with your own. No, it is you that is the engineer that has the authority to put your column or to place your column point, to decide where your column points are going to be. Okay, that's fine. So with this now, I'll go with that. So I'll copy again now, copy this right now, and then come here, click on make sure your columns are placed at the center point of the grid lines. Okay, that's fine. Although there are some times that you are to also to recess your column out from the center point, but that is a different gain altogether. Okay, that's fine. So with this now, I will then go again and then come here and place my column point here. That's fine. Come again, and I want to place my column points here. Now, knowing that I see that the column point depends solely on you as a structural engineer, you have to follow just the rules by what? Column to column spacing less than 6 meters, and also let your column be hidden inside the wall if need be, except there is need for it to be exposed. Okay, that's fine. So with this now, I'll then come again and place another one here. Again, I'll come again and place another one. I'll place one here. That's fine. And I'll come now and place one column here. That's fine. And I'll come again now. Let me see. And I'll place a column here. Let me see. From here to here, from here to here, from here to here is not that long. That's fine. I'll come again now and place this here. Now, how I place my own column points, when you are going to practice on your own design or that you using this building plan or another one, you can choose to place your own column points differently. The whole end point is that let the building be what? Stable, and let the building cost for the construction not be too expensive. Okay, that's fine. Sorry for that. Okay, that's fine. Sorry for that. So in knowing that now, we then continue again. I'll place my column point here, and I'll come now. This is a major beam coming from all the way down here. So I'll place one here. I'll place one here, and I'll place one here. That's fine. And I'll come again. I'll place another one here. That's okay. And I'll come now and I'll place one here. That's fine. And then let me see again. I'll place another one here. Let me see that. This point, zooming one here. That's fine. Okay, that's fine. So you can see now. Now the question now will now be, how do I treat this place here? Because here it's titled large open what showroom. So there is nothing that's happening here. It's just a large showroom. So let's see. So You can see it here. So it is like a large showroom. There is no intermediate block walls, okay, and all that. So you have to mind how to play your columns around here, because if you place columns anyhow on this building, it will deface or it will cause obstruction to the usage of this showroom here. Okay, so you have to make sure you plan how you have to place your columns around the showroom here. So with that now, I'll just use two columns alone to carry these beams around here, and those two columns I'm going to place them at the midpoint. Let me just copy this right now. I'll place those two columns now. I'll place one here, right, and I'll place one here. Other persons or other engineers can choose to place 1, 2, and 3, and 1, 2, and 3. But for me, I want just these two columns alone to carry. Whereas if you check the span of this spacing from here all the way down here, I think it's like this is just 4 meters. So I think it's okay. It's less than the 6 meter. So since this is less than 6 meter, it's perfectly okay. It will stand perfectly. Okay, that's fine. So the same thing happens here. If I now check again from here to here, okay, that's fine. This is what 3.63. Okay, that's fine. That's okay. So as long as your column spacings are less than 6 meters, you are good to go. But please let it not be too close to each other. Don't go 2 meter columns spacing are too close to each other. But I'm just choosing to allow this one here because this is already around 1 centimeters. I think so on 900. Let me see. Yeah, I'll choose to allow this here because this is a staircase around here, and this is a straight flight, and this flight is a very long straight flight. So I'll choose to allow this column here because of the load or that this staircase is going to put on this beam here, okay, that's fine. So I'll leave that. Okay, that's okay. Now you can see that something just occurred. Now you can see that if I when I click this line, this wall, you can see that it tends to select all the walls together. So I'll have to explode each of these walls, okay, so that they can be a single unit. Okay, that's fine. It's like individual stuff. Okay, that's fine. So I'll come now, click on this, right click until it was less similar. All the walls now are what's selected. Okay, I'll come now, hold my shift key and select the original one here. That's fine. So I'll come now and type X, enter. X means to do what? Explode. Okay, so you can see that each of the walls now are now on their own. Okay, that's fine. The reason why I did that is because if you export that to the software Protastructure, you won't be able to see this line of wall because it will not appear because they are blocked. Okay, only columns that should be on polylines. But apart from that, any other polyline that you put in there will not appear. Okay, because they are blocked elements. Okay, that's fine. So you do what you just have to do what explode them. Okay, that's fine. Even these doors now, you can see these doors now, they are blocked. For it to show on the software, you must have to do what? Explode them. Okay, that's fine. So I'll just come in right now, right click now and do what? Say select similar. Okay, that's fine. Let me see again here. Select similar again, and then come here and select my original. Select holding shift, highlight, and that's fine. Then come now, type X, enter, and then you have each of the doors now. You can see that separate. Okay, that's fine. That's okay. So with this now, you can see that we have now done what? Placing all our column points. As long as all my column points, all my column spacings are less than 6 meters, it is good to go. It's good to go. Okay, that's fine. So with this now, like I said again, let me just recap again. Let me just recap. Column points or position depends solely on you as a structural engineer. You have to brainstorm, think about how to place your column points. Now, just to help you on that, you have to look out for the strategic points where your major members are connected or connecting. For example, you can see that this joint now is a major point where these four beams are meeting. 1, 2, 2, 3, and 4. This point here. So there is no way I will now come and do what? Come now and put my put this column, let me say, to be here, all right? And again, do now and again now to be here. It doesn't make sense, all right? It doesn't really make sense. So instead, look at the strategic points. Just say you enter, you enter. Okay, that's fine. Because you means what? Undo. So look at the strategic points. Now, once you've picked at the point, or okay, now that we're gonna this is an edge now, we cannot just come and put our column, let me say, here. It doesn't really make sense to be here, all right? Why not push to an edge? So the best thing, this is the point where they will meet. Why having a small cantilever beam that will be here? No. Instead, as long as this point will not disturb the appearance of a structure, push it there, okay? Put it there. Then the next thing I now think of now is to now do what the column spacing, which I've told you the rules. Make sure that your column spacing between each other is at least not more than 6 meters, right? So play with 5 point something, 5.5, 5.5. I think 5. I would advise 5.5 below, except there is there is a need that the span is to be longer. For example, if this place is to be a driveway for different vehicles to pass through, then you can then further do what? Have your column spacing from here to be what? To be your column spacing. That means that this column here won't be here. Okay, that's fine. I have done before 13 meters. Okay, now if I check this building span now from here to here, this is less than 12 meters. Let me see. Yeah, this is 10%. So I had designed 13 before. That means that there was no column here, here, here. Okay, these are just removed. So I have designed 30 meters before, which I have just 2 columns. All right, I know that. Although that is a different experience altogether. So with this now, we are done with this structural framing here. Now, once you're done your framing on your ground floor, now, yeah, correct. The question now will be, where do you perform your structural framing? Note, it is best to perform your framing on the ground floor plan, because it is from the ground floor plan every other plan floors are being created from. Even if you have a basement, it is from the ground floor plan that from there they will not create out the basement. So make sure you start your structural framing from the ground floor plan. Okay, it is from there you now begin to copy your columns to other ones to check if they are going to appear on empty space. So now, once you're done with your column points, all right, once you're done with your column points, all right, on the ground floor plan, the next thing now to do is to copy your column. There is what we call structural superimpose of members. So you have to copy your columns and superimpose them on the first floor plan or other floor plans. The reason of doing that is to see if the columns on the ground floor is going to appear on the first floor or other floors on an empty space, because most times the column that appeared inside the wall on the ground floor might end up coming to appear on empty space, something like this. Let me say something like this. And when this happens like this, it's not nice for the people using this structure. Imagine that as you are now in your room, where your bed is, one column is just standing where your bed is. It doesn't make sense at all. So nobody wants to have that. All right. So you must have to make sure that your structural design is as simple is as simple as anything. All right. Yeah. Make them to wonder where the columns on these buildings are. All right. Don't just display your columns for everyone to see, and don't disturb the people using the structure with your columns anyhow. Okay, that's fine. So I'll do right now, enter. So once you're done with your structural framing on the ground floor, then you have to do what? Copy the columns only to other structural to other floor plans to see if the column points on the ground floor are going to be the same, if they will still be hidden inside the walls, or how they will appear on other floors. Okay, that's fine. So with this now, I'll click on this now on one of the columns, right click and do what? Select similar. If you are using lower version of AutoCAD, this might not work on your versions. I know that I'm using 225 version of AutoCAD. That's fine. So I'll come now, I'll do what? I'll type CP Zip means copy, enter. Now, when you are copying your column, make sure you you look out for the where they have where is the same where like a reference point where is the same for the ground floor, first floor, second floor, and so on and so forth. So the best is if you have a lift on this on the plan, the point of the lift or the edge of the lift is should be your reference point because lift point does not change. All right, is the same for all the floors. Two is the staircase. Look at the point where you have your staircase. Staircase point does not change. It's the same for all the floors, except maybe they want to change the stair or terminate and then continue from different place. Okay, that's fine. So with this now, if I look at this ground floor now, I have a staircase here, around here, and also here. Okay, and if I look at here too, I still have the same staircase here and staircase here. So what does it mean? It means that one of these points here might be the same thing, the same reference point which I have here, which I have here on this place is the same thing which I also have here. Let's just try it now. So I'll come now and copy the columns, pick here, click on this place here, all right, on the edge there, and then move. You can see that I'm moving on the columns. Can you see that? I want to superimpose the columns now on the first floor plan to see how the columns will appear if they are going to cause obstruction to the people using this first floor plan on that. Okay, that's fine. So I'll come now and then place this here. Okay, that's fine. And press escape. So I'll now check now to see how the columns appear. If they are appearing on the walls, then it's perfect. So you can see right now that all the columns now are appearing on the walls. Basically, this is a simple structural building plan for everyone to start with, okay? But there are some complex structural building plans which you're going to have that by the time you superimpose, you will see that your column that appeared well on the ground floor is appearing on empty space on the first floor, indirectly causing obstruction to people using this first floor. That so with that you have to remove or terminate the column to stop directly on the slab. Okay, although we have done many videos on that before. Okay, on our channel. So but for this case, you can see that all the columns now are appearing on different on the same point, still hiding inside the walls. Okay, that's fine. So now that we have done a superimpose now on this building, and we have seen that all our columns are appearing or are still appearing inside the walls, then we can now move on to now for the structural modeling. So once you have done this, right, now you can see that how we have placed all our columns. Now we now have to do what? Save this building plan now differently, because now this now becomes our structural framing. This is what they will use for the structural setting out of the building, which we are going to use during the building construction. Because I said again, I will walk you through during the construction. You will see how we are going to cast this column, do everything, all right? How we are going to construct this building. Okay, that's fine. So with this now, I will then come now and click on this. Now for it now save. Now that we have different building or drawings here, we want to export just this one alone. What do? I'll have to do what? Highlight this one, type W, enter. That's a command to save just that particular drawing on its own. I'll then come now, click on this icon here that has 3 dots on it. Click on it. Then I will then come, I will have to choose a place. This is for a client, so it's on the desktop. I'll come here, Udo Bata. This is a very renowned fashion designer that owns the building. Yeah, in Port Harcourt, Nigeria. You can check it out. You can check it out on Google. udobata.ng. Udobata. Just this name here. .ng. Okay, so I'll come now and save it inside here. So I'll come here now and type Udobata. Now note, every building plan that we use to teach you guys here, we have already taken permission from the clients. Anyone that we don't display the like we don't show the building plan or for you guys to use and Potato to use, that means that we don't have the permission to use it from the client. But this one now, we have gotten the permission already to use it to teach. Okay, that's fine. So with this now, I will then type do better. Let me say structure. That's short form of structure GA. Now GA simply means what? General Agreement what? Drawing. So I'll say GA or structural plan. Let me just say plan. That's fine. Now make sure you choose your file format must be DSF. Alright? Knowing that AutoCAD save drawing with two formats, DWG and DSF. DSF is a format that interfaces with most of the structural design softwares, okay? And we are using the software Protastructure for our design. So I'll make sure I choose what DSF for that, okay? That's fine. So with this now, I'll then come now and do what? Say what? Save. And I'll come here and do what? Say okay. Watch here. It has saved. If I now navigate now to my desktop, minimize now to my desktop now, and look at the folder Udobata Plaza, which is here, you can now see that we have you will see that it will display now. You can see that right now. This now becomes our structural plan. Now, I am using 2024 version of Protastructure to design for this building, for this structure. Now, from version 2021 of Protastructure and above, basically, let me say 2022 and above, if you want to export your structural model or plan from AutoCAD to the software for design, you must place your structural framing plan at 00 coordinate. It's a culture you have to obey. Okay, that's fine. So I'll have to open this plan now, open it now, and then once I open it now, you see that we have under plan only. You can see that right now. We don't have any other one again, except the one that we have saved. So this is the one we are going to export. So I'll type LW, enter, just to on the line weights that we used, okay, and say okay. So right now, you can see that this plan now is not at 00 coordinates, okay? So I want to place this drawing now at 00 coordinates. Now, there is a reason for that. If you don't learn it, you might export a small building plan to 2022 version of Protastructure and above. It will appear well. But when you are dealing with massive structure, massive building plan, you will see that if you don't put it on 00 coordinates, you'll be having issues on your design. Okay, that's fine. So with this now, I'll have to do what? To put this plan on 00 coordinates. And how do I do that right now? I'll do that by doing what? Type L, enter. And I'll type 0 tab 0, enter. Automatically, you see that your a line will display. Now you can see that this place is showing what? L X axis and Y axis. Now there's a point giving you there, right? Now if I click anywhere now, right, and press enter here, I have 2 points. The first is the free point here. The next point here is at the point where we have the what? The X and Y coordinate. Now this point here we have X and Y coordinate now is our 00 point coordinate. Now you can see where our building plan is very far away from the 00 coordinate. So what I do right now to put this plan now on 00 coordinate, I will highlight this plan now and move it. I'll pick a point from this first place here, and I'll move it now to where we have our first what? This X and Y coordinates. Where we have this first line of this blue line, and put this here. Automatically right now, this plan has been put to 00 coordinates. I'll then escape and then come now and delete this one now. Delete. That's fine. You can see that the X and Y coordinate now is directly on our building plan. Can you see that right now? Can you see that? Correct. So with this now, we have placed this building plan at 00 coordinates. So whatever thing we are going to model, we are modeling it at 00 coordinates. The importance is that if you want to export your structural model to software like SAP 2000, Tekla Structure, Revit Structure, and all other BIM model, if your model is not modeled at 00 coordinates, you will see that you will have issues on exporting, or when you export your model to Revit, to Tekla structure, SAP 2022, you see that you begin to have issues on your on your modeling on that side. So make sure you, now that we have BIM model interface, make sure you begin to do your modeling on 0, 0 coordinates, and you begin that by making sure that that your structural framing plan is at 0, 0 coordinates. I hope that's get right. That's fine. So with this now that we have placed it now, we then come back again and do what? Say Control X, which is to do what? Save. Now make sure you save again as DSF. They will ask to replace. You say yes, replace it. That's fine. Okay, that's fine. So then now do what? Close. They will ask you to change to DWG. Say no. Just say no, because once you say yes, you have changed the format from DSF to what? DWG. So it's always say no. That's fine. So with this now, we have now saved this file you are seeing here now at 0, 0 coordinate, and also at and the same thing as DSF. So with this, we have now performed the structural framing for this building you are seeing here. That's fine. Okay. Now we have now done the first phase, which is planning, preparing the structural framing of a structure or of this building. The next thing now to do is to export this plan now to this software, Protastructure 2024. Okay, that's fine. And then begin to do what? Begin the structural modeling. From next week, I'll be teaching you guys Aviva E3D for people that are moving into oil and gas too. Okay, because structural engineers also have their own phase, their own work in oil and gas sector. Okay, so I'll teach you that too. That's fine, because I work in oil and gas sector. I was in the construction site before I moved to oil and gas sector, and then before Ekidel now came into existence. Okay, that's fine. So with this now, we have now done, sorry, not this design. This is for a flat slab, I'll teach you that later. So with this now, we have now done the structural framing for this building. Okay, so I would like you guys to repeat your own on this one. All right, if you have this CAD file, again, to get this CAD file, you can see the link down below. All our CAD files are below $1, so that you can be able to afford. Now, the reason why we don't give it out for free is because if you get something for free, you won't value it. But just to bring down the price, just to be able to see that we are helping you guys, we put it at $1. Okay, that's fine. That's okay. So right now, we will then move on to the part 2, which is now the structural modeling of this building you are seeing here. So we are going to model this structure on the software Protastructure 2024. If you don't have the software, you can contact us. It's not free, it's for paid. Okay, that's fine. So see you there right now on the part 2 of this building design. That's fine. I remain your friend, Justice Umoka. See you again on the part 2. Bye for now. Before you go, please share this video to your friends and colleagues, to your friends in school and all that, so that they will also know how to design structures your code. And also recommend them to Ekidel. Now, if you want one-on-one mentorship with Ekidel or with me, you can enroll for Ekidel one-on-one mentorship training, where at the end of the training, we give training certificates for what for competency of your design, and that then you will it runs for 6 weeks, and that for 6 weeks, although you can it can run up to 8 weeks depending on the days that you mix, and that for your training. Okay, that's fine. So see you then on the next part, which is the part 2. Bye for now. Love you.